Hello everybody, my name is Hicham Koraichi and I'm here to present to you fluid mechanics. So first of all, what is a fluid? A fluid is a substance that continually deforms under pressure. Fluids can be liquids and gases, and fluids have definite size but not shape, while gases have neither definite size nor a definite shape. And fluids can take the shape of any container. We said that a fluid is a substance that continually deforms under pressure. So what is pressure? Fluid pressure is the amount of pressure present in a fluid, and it changes and depends on the depth of the fluid. The more we go down, the more pressure there is. An object placed at a higher depth experiences more pressure than a similar object at a lower depth. So if a person dives down deep in the pool, he's gonna experience more pressure in his ears than a person at a more shallow level. And pressure is defined as a force per unit area, and it is usually more convenient to use pressure rather than force to describe the influences upon fluid behavior. The standard unit for fluid pressure is the Pascal, which is a Newton per square meter. Difference and similarities between liquids and gases. Fluids have a definite size, as we said, but no shape. Gases have neither a shape nor a size. They both take the shape of the container, and fluids are slightly compressible, but gases are highly compressible. They can both flow, and fluid particles can move freely but have to stick together, unless you split them. But gas particles move freely and do not have to stick together. So, have you ever wondered how huge ships can float on water? So, Archimedes' principle explains this. Archimedes' principle states that if an object is submerged in a fluid partially or completely, it raises the level of water, and that is due to the fact that it experiences an upward force called the buoyant force that increases the level of the water, which is equal in magnitude to the weight of the fluid displaced by the object. And this is how they measure the volume of an object using water. And this explains why when you get into a bathtub full of water, you watch the water level rise higher. So, how to calculate this force that pushes these heavy objects upward, the buoyant force? We first have to find the volume of the submerged part. We find the volume by using the formulas length times width times height for a cube, or 4 over pi r cubed. Then we have to find the density of the fluid. The formula is mass over volume, but it's better to look it up for more accurate responses. We then have to include the downward force, which is gravity, that pushes that pulls the object downward, which is 9.81. We then have to multiply the volume we found first, the density, and the downward force to find the buoyant force for a floating object. So, lastly, analyzing Pascal's principle. Pascal's principle states that pressure exerted anywhere in a confined incompressible fluid is transmitted equally in all directions throughout the fluid, such that the pressure variations remain the same. And this works, for example, when you want to use the toothpaste. You put pressure, the toothpaste comes out.